be more than happy to elaborate on on anything that comes up throughout the presentation. We can get into it in more detail during the Q&A. So the topics I was asked to focus on by Stephen and the team it was ventilation generally, but more specifically, we're looking at current trends in the ventilation industry, challenges that the industry are facing at the moment, and potential future trends as well. So just to introduce myself, as Stephen said, my name is Dara McGowan, and I'll be a director in Partel UK. My details are on the screen there, but I can pop them in the chat at the very end anyway if anyone wants to get in contact. So I tried to break it down into different sectors, I guess. First thing I'm looking at are the current trends in the domestic ventilation market, and they differ quite a bit from the non-domestic. In terms of domestic ventilation, because of the new regulations that came in with the new Part L in 2019, which requires an air tightness of no higher than 5 meters cubed per hour per meter squared, and the requirements that came in Part L, which require mechanical ventilation if you go below 3. The vast majority of new build domestic projects have moved towards some form of mechanical ventilation, and that's basically driven by we're achieving much more airtight buildings now. We're kind of limited to how leaky they can be by Part L, and to hit 5 exactly is quite challenging. So people often end up having a building that's more airtight than 3, and they're then legally required to put in mechanical ventilation. For the most part, developers are using continuous mechanical extract ventilation. So for large estate projects, it tends to be CMEV of some sort. That can be with or without humidity sensors. It can be centralized or decentralized. And then one-off projects, people who are doing self-builds and so on are moving towards mechanical ventilation with heat recovery in lots of cases. I guess they just know the benefits of that, and they're seeing the payback period and so on. And so in my experience anyway, and for everyone in our office, it tends to be larger developments are going for extract only without heat recovery, and one-off builds then are going for MBHR. And we do quite a few of both of those types of buildings. More recently, we've seen we've seen some of the higher end developments moving towards MBHR systems. And just chatting to the developers and the funders of those projects, that's basically in a response to demand from the potential buyers. It seems that homeowners have a better education around ventilation now. They're asking for MBHR units. It tends to be that they ask for the unit, but then once it goes beyond that in terms of efficiencies and specific fan powers, it goes a little bit over people's heads if they're not in the industry. But homeowners have started asking for MBHRs, particularly for the higher priced developments. Natural ventilation, while it's still technically allowed in Part F, it's become extremely uncommon in domestic situations. I've seen maybe 1-2 projects that are using natural ventilation since 2019. So it's super rare that that's actually the case. So where ventilation systems are being retrofit in domestic scenarios, we get a mix of kind of inquiries or interests. It could be either CMEV, MBHR, or a mix of both. We can actually kind of mix both together when we're using decentralized systems. And the typical driving factor for requesting a ventilation system to be retrofitted in someone's house is mold. So the most common reason that people call us to retrofit ventilation systems is kind of mold issues and things around that. In terms of the non-domestic market, then the current trends are quite a bit different than the domestic. With the greater awareness of indoor air quality as a result of COVID, we've had a huge increase in volume of inquiries for offices, schools, and creches. There'd be 3 building types that have, in terms of inquiries, they've tripled or quadrupled over the last 2 years from what we would have had pre-COVID times. And so lots and lots of our larger retrofit projects are those types of buildings. There can be challenging buildings to ventilate adequately for a couple of reasons, I guess. Density is the first issue. So, for example, this is an office block. It's just one floor of a 4-story office block that we're working on at the moment. There's a lot of people per floor, and we need high flow rates to achieve indoor air quality that's considered best practice. We also have the issue of multiple stories. So for example, you can't put units in top floors and then ventilate all the way down to the bottom because there's high pressure losses. That could be a challenge. And then particularly for the likes of schools and creches, while they're single story, they have flat roofs. So hiding ductwork can be quite challenging in those particular buildings as well. In our experience, we've found the centralized units are often required for classrooms or open plan office spaces, just because there's so many people in a classroom. You know, typically you'd have, let's say, 30 kids and maybe 2 or 3 adults in a room. To achieve the flow rates you need for that with decentralized ventilation can be a challenge. So for more densely populated rooms, we tend to go for a ventilation unit just for that room. So it's difficult to get a system to do a whole school, particularly in retrofits, because they can be quite sprawly buildings. They're hard to cover with one unit. And so we have put units just to deal with individual rooms. And then for lower population rooms like offices, the principal's office, the staff room, individual offices like you can see on screen here, we tend to use decentralized ventilation for those particular types of projects. But it does vary on a case-by-case basis. So you can see, for example, this is a school, it's an assembly hall. They can have quite a high occupancy, but for short periods of time. And we installed 2 next decentralized units in that excuse me, particular project. So we normally go on a case-by-case basis, but those higher occupancy rooms are difficult to do with decentralized. With these particular projects, you know, while property managers are keen to upgrade ventilation requirements, when you tell them what's involved in achieving, you know, top class kind of best practice flow rates, they kind of tend to not want to go for that option because of cost. They're more interested, it seems, in our experience, in achieving an improvement to the air quality. So they kind of see it on a spectrum as opposed to good indoor air quality and bad indoor air quality. And the key drivers that they tend to refer to are things like, you know, can we see mold in the rooms? We want to get rid of that. Is there noticeably poor indoor air quality? And that would be determined by odor or, you know, stuffiness or something like that. They essentially just want to try and fix indicators that are noticeable and tend to be less inclined to go for the kind of the full hog ventilation rates that we might recommend. They often want us to kind of meet them in the middle. Oftentimes as well with projects like this, you know, whether it be right or wrong, or, you know, people have different opinions on this, it does tend to be a combination of mechanical ventilation and natural ventilation that is kind of contributing to the air quality in these types of buildings. Again, just due to difficulty of install, budget restrictions and so on, we often end up having to put a caveat in our designs to say, look, because of the amount of ventilation you've allowed us to supply, you do have to supplement that with natural ventilation. In terms of challenges for the ventilation industry, a large one will be the validation process. Again, I don't know kind of who's on the call or how familiar people are with the ventilation validation process, but it's been a requirement since 2019, where an independent validator comes in to check the project's ventilation system at the very end. So that would normally be an NSAI registered independent validator. There have been some problems with that scheme, quite significant issues actually, and they are being worked out still. So we're well into 2022 and we still haven't got a fully ironed out system. In terms of the problems that we're facing, there's a lack of compliance. We know that there are more houses being built than independent tests being booked. And in that sense, we understand that some people are not actually complying with that part of the regulation. It is a legal requirement now, so you do have to have an independent validator. It does tend to be, you know, validators do tend to be kind of employed to come to apartment blocks and large developments where building control are a little bit more switched on. So for the most part, they are happening in developments and apartment blocks. But for one-off houses, we know from the figures that not a lot of one-off homeowners are actually requesting independent validation. We have had an issue over the last couple of years with assigned certifier knowledge around this area. Ultimately, if the assigned certifier signs off on the project without a validation, building control they just accept it. Again, it's a manpower issue, but we really need assigned certifiers cracking down on that independent validation requirement. They have started to become more and more aware of it, particularly with extra courses, extra training and stuff like that. And I know the Department of Housing have really put a push on building control and assigned certifiers to ask for the validation. I'm going to cover that in a little bit in just 2 or 3 slides. So that has started to improve even as recently as the last couple of weeks. So that issue is being addressed slowly. Then in terms of the compliant rate with houses that are actually tested, so I spoke to 2 of the most active testers in the country this morning just to get a sense of kind of their pass rates, fail rates, and Gary O'Sullivan from NSAI would confirm this. Most houses are failing. So when a house actually gets independent validation, a large proportion of those are still failing that validation. So even the ones that do opt in, oftentimes aren't actually compliant. The main reasons for failure seem to be poor ducting, which results in under-ventilation. So for example, a system is installed, it's been designed by a manufacturer to have certain flow rate in the bedroom, for example, but the duct runs that bring the air from the unit to the bedroom are all over the place. There's too many bends or something like that, and the pressure losses result in under-ventilating in that room. Another major issue we've had is no commissioning sheets presented to the validator. The independent validator has to receive a commissioning sheet or it's an automatic failure. And in lots of cases, people are not providing those. Inaccurate equipment is a major issue as well. So even if there is a commissioning sheet and somebody does go and commission the system, there's no one checking their equipment to make sure it's accurate. Basically, what that means is they typically have a flow reader or an anemometer thrown in the back of the van somewhere. It's never calibrated. They might commission the system to be perfect on their own unit, but the independent validator has to use a calibrated, well-maintained piece of equipment, and those figures can be out by quite a bit, and therefore result in a failure as well. And finally, we have an issue with control indicators. So it is a legal requirement to have an indicator inside the building somewhere, so not up in your attic, that shows the system is working. It's an automatic failure when you don't have those. In terms of future challenges for this particular process, NSAI only currently have 36 registered validators. I actually used to run the proficiency test for NSAI as well. For the test they have to do before they become a validator. So I spoke to Emer Doyle, who's running that facility at the moment, just during the week in preparation for this presentation. There's currently nobody registered to do that test. So we know that we have 36 registered validators and we don't have anybody feeding through to increase that number. Now, if we are to meet the building targets that the government have outlined over the next couple of years, we just won't have enough validators to physically carry out those tests. I don't want to dwell on this one for too long, but in terms of the validation process, and if anyone wants to get into that side of things, there are essentially 3 steps. You have to complete an NZEB ventilation course. That is optional, but it's strongly recommended by the NSAI. We've had nationally about 450 people pass through that course. That's the NZEB ventilation course I referred to earlier. And that course is currently offered by WWETB and LOETB, and soon in Limerick Clare also. So we're spreading that course. I guess the ETBs are all getting up and running now. They're offering that course on a regular basis. So if you're interested, you can reach out to either of those parties. You then have to do a ventilation proficiency test, which is carried out in Enniscorthy. That's just a test that you know how to use your equipment and that your equipment is calibrated. And then finally, you have to do an NSAI validation test with Gary O'Sullivan. And again, if anyone is particularly interested in the validation process, I'm happy to elaborate in the Q&A. I'm just keen to leave some time for questions at the end. Now, in terms of future trends in the market, as I mentioned, we are starting to see building control and assigned certifiers becoming more educated around this particular topic. So this is a quote that came out to, we have an architecture office actually that works right next door to us here in Galway. This quote came out from building control in Galway. It basically said to all agents, for your information, I wish to inform you that I will be requiring the upload of a ventilation validation cert for all future submissions. And this would be in addition to uploading a commissioning cert. Long story short, that's a direct kind of a feedback loop from a presentation that the Department of Housing put on for building control a couple of weeks back. where they done presentations on the importance of the ventilation validation and the commissioning process. Just from chatting to some of the lads as well, the validators this morning, that's come out in other county councils as well. So building control are going to start to require this. So hopefully, as we start to move into the future, we get a really kind of a clamping down on the validation process, which will improve the ventilation quality across the board. So from, again, talking to different stakeholders in the industry, from you know, working in the industry myself, this is the way we kind of see things going. So the ventilation design, that has to be installed correctly. It has to be commissioned correctly. Then we need independent validation to be carried out. And finally, building control need to start clamping down on the certs that they receive. So in terms of how I think all of those factors are going to change slightly in the future, with ventilation design, manufacturers are going to have to start providing Part F compliant designs to support their sales. Now that is happening for the most part, but I think what could be important there is that manufacturers supply designs in a way that's easy to read in a commissioning cert and for the validator. It's an easy way to support the sale, I guess, but manufacturers do have to ensure their Part F design is completely compliant and clear to the installer. Installer competency is actually required, so you're not supposed to install a ventilation system unless you're competent, same as a designer. But because installers don't tend to sign off on any paperwork, there's not a very strong paper trail there. So it's not being policed. And I know for a fact that it's not the case for most installers. Most people are just installing systems. That can be problematic because, as I said, when ductwork is not running correctly, it results in pressure losses, and that's why we get the low readings at the diffuser in the ceiling. That's why we're under ventilating in many cases. Personally, I think that issue is going to be solved the hard way, essentially. Like, as building controls start to require more and more certs, and we start to get more and more failures, that would put pressure on installers to actually install the system correctly. You know, if an installation is done incorrectly, there's no hiding from that anymore, because hopefully every house will have a cert to prove the system is working. In terms of the commissioning process, then, that needs to improve as well. We basically need to, again, as designers, supply a proper commissioning document with every design that we, you know, have put together. And then the guys actually commissioning on site need to use calibrated equipment. I was chatting to Owen McGann this morning from 2EVA. He'd be a really active validator. He was telling me that, you know, it's super unfortunate, but he turns up on sites where people have really put effort into the commissioning. They've got their anemometer, they've tested all the flow rates, everything is perfect. But when he tests the flow rate with the same type of anemometer, the same brand, the numbers are different. But it's because, again, the commissioning, people who are commissioning they're not legally required to get their equipment calibrated, while the independent validator is. The validator is working with a calibrated machine, the commissioner isn't, and the numbers aren't matching up. Now, that is really frustrating because people who are commissioning the system are putting the time and effort into that, but because their instrument is inaccurate, it results in a failure. And so that's going to have to be improved as well. In terms of independent validation, then, we're going to need to grow the validators list. That's why I wanted to go through what's involved in becoming an independent validator. If we do end up building to the volume that the government have recommended, we just don't have enough independent validators. We need validators to be more vocal about their common issues as well. So even from my prep for this morning's presentation, I was chatting to different independent validators. They all have the same issues coming up again and again. But I think a lot of people aren't hearing these issues. They don't understand where the most common flaws are in the system. So I think they could be more vocal to improving the system. And then finally, building control across the country are becoming more aware of Part F. As I said, there was a memo went out from the Department of Housing. Building control are starting to clamp down on that. So hopefully that should improve things. In terms of future trends, then, I think there's going to be simplified solutions. I think the method of kind of traditional commissioning is, I guess, open to issues with workmanship and problems on site and so on. We like to look at the German market in terms of ventilation just because they're really well developed in terms of their ventilation strategies. and a large proportion of their ventilation market would be decentralized MVHR. And there would be quite a bit of the 30% of extract systems decentralized as well. And that number is growing all the time. I think that's quite a, I guess, it's a logical way to go because it takes out the issues with pressure losses because of ducting. You don't have to adjust diffusers to make systems work correctly and so on. Commissioning is essentially done through a control panel. And because, again, there's no ductwork involved other than right through the wall, there aren't those pressure losses associated with centralized systems. Now, that's not to say decentralized is the solution for every project. We actually do design and supply centralized systems as well. But I think intelligence around controls, around commissioning and so on, are going to make things a lot easier, and you're going to be more confident going into your independent validation. I just wanted to finish with this image. It's a kind of a strange one. It came up. We're doing some retrofit work for the Dublin City Council on their housing stock. So it involves going in, doing surveys with homeowners, checking the humidity and mold issues and so on, and then coming up with a ventilation strategy. But I think the future trends of the market are going to depend on homeowner education. So Shane, one of our colleagues, sent this into our kind of group chat the other day. If you're wondering what that is, that's a ventilation, a background vent stuffed with a t-shirt and a pair of runners so that no air can get through it. You know, so we really need to actually focus on education. I think when you're in the industry, it's easy to kind of believe that everybody is on board with ventilation, everybody understands the importance of it. But this only came in last week. But this is the type of thing that we're still seeing on the ground in reality. I think education around ventilation is really going to, I guess, form the future trends moving forward. So I have no idea, Stephen, if I'm over time or under time, but I guess we'll open up for questions.
Yeah, that's perfect, Dara. No, you're perfect. You're good on time. We have a question in from Stephen. It says, for MVHR units in non-domestic buildings, can the units be turned off out of hours, example, during summer holidays, or do MVHR units have to be left on all the time but at a lower flow rate?
Yeah, so it's a good question, and it's kind of like I was saying with non-domestic buildings before. They're not as well regulated as domestic buildings are, but they would typically be set up on a timer to increase and decrease flow rates based on occupancy. So it's not a case of, okay, you know, someone has to switch the unit on and off. You can build that into a timer system. The only issue that we do need to watch out for are things that will build up even when the building is empty. So if you're in an area of high radon, for example, we just need to make sure that that doesn't become an issue overnight. But it would be kind of standard practice to increase and decrease ventilation rates based on occupancy. You know, a really common one too would be purging before and after. So, you know, you might purge, ventilate before school starts for all the kids come in to get a good, clean, fresh air. And then when they leave or in between classes, you can purge as well to increase air changes during that period.
Excellent, yeah. And also another question here is the ventilation validators required for installations in non-domestic buildings or only in domestic buildings?
As far as I'm aware, it's in non-domestic as well. It's a little bit grey in Part F, and non-domestic, you know, to be quite honest, is not that well covered. It's a hard requirement in domestic. Non-domestic, it's not as clear, if I'm honest. I don't know the answer in black and white.
That's perfect, yeah. And the last question.
Sorry, go on, yeah.
Last question then is, I've heard decentralized MVHR is not great. Can you clarify when and where it is best used?
Yeah, so you know, there's, I guess, pros and cons to all the systems, but we use decentralized MVHR in domestic, non-domestic, new build, retrofit. It just depends on the house type, on the situation, the scenarios, and we actually do have centralized as well. So if homeowners or, you know, project owners don't want to go for decentralized, we can explore centralized as well. But really finds its niche in retrofits, number one, for obvious reasons, you know, if there's no room for ducting and things like that. But also in projects where people just don't want to drop ceilings for whatever reason and don't want to run ductwork throughout the building. So it'd be quite common in residential developments, just from a cost perspective, you know, it could save costs in terms of having to drop ceilings and all that sort of stuff. So pros and cons to both, I guess, and that's why we carry both in our range.
That's perfect. Yeah. Well, thanks very much, Dara. It's brilliant.
No problem.
Again, for everyone that's here, I forgot to send out. Well, I didn't forget to send out the email today, but I just wanted to see if I didn't send out the email, what would happen. And it turns out you can get more people if you send out the email. But it's a pilot scheme. We're figuring out slowly as we go along. So that's kind of the good bit. So yeah, I'd like to thank everyone for coming today, and I'd like to thank Dara for a wonderful presentation on ventilation. It was very interesting, especially the validation process you were talking about. It's put a lot of ideas in my head anyway. I don't know if anyone else, but
good.
So
thanks for having me.
Perfect. So thanks everyone, and see you again.
Thanks very much.